Okay, welcome back. We're continuing with differentiation of inverse tangent function. On to problem 2, the derivative of the inverse tangent function of x over x minus 4. Step 1 of the algorithm, identify function type. This again is an inverse tangent function. Step 2, apply differentiation rules. In this example, we have a chain rule scenario. We want the inverse tangent of a function. So we're going to use our second inverse tangent differentiation rule. The derivative equals 1 over 1 plus the function, which is the argument of the inverse tangent, squared. We'll have x over x minus 4 squared. We're going to multiply by the derivative of that argument. So our inner function is x over x minus 4. We want the derivative of that function. Now, looking at our algorithm, we are at step 3. If necessary, use product or quotient rule. So we do have a scenario in which we're going to use the quotient rule. The quotient rule is in evaluating the two functions we're given, which are x in the numerator and x minus 4 in the denominator. We're going to multiply first the derivative of the first function. The derivative of x is 1 times the second function, x minus 4. We will subtract the original first function, which is x, multiplied by the derivative of the second function. The derivative of x minus 4 is 1. And in the denominator, we'll have the second function squared, x minus 4 squared. So I'll note that along with step 2, we have used step 3. And in fact, we've also used step 4, the chain rule. I'll go back over to my first example and also add in the note that we have applied step 4, chain rule, based on the selection of the second inverse tangent differentiation rule, which has the chain rule built in. Same is happening in example 2. On to step 5, simplify. We're done with the calculus. At this point, we're simply going to do algebra to simplify the right side of the equation. I'll start with the first fraction. What I have in the denominator, the second term of the denominator, is quantity x over x minus 4 to the power of 2. I'm going to distribute the power of 2 to have x squared over quantity x minus 4 squared. As is, we're adding 1 to this term. What we want to do is create a fraction with the 1 so that the denominator matches the second fraction here that we've just manipulated. So let's change 1 into x minus 4 squared over x minus 4 squared. And now we can add those two fractions in the denominator of the main fraction. We're at this point 1 over, a rather complicated expression, times another fraction. 1 times x minus 4 is x minus 4, minus x times 1 is minus x, over x minus 4 squared. Continuing with our simplification, we have 1 over, and now in the denominator we will combine the two numerators, x minus 4 squared plus x squared, all over the combined denominator of x minus 4 squared, times x minus 4 minus x is negative 4, over x minus 4 squared. Notice in the first fraction we have 1 divided by another fraction. We can change that to 1 times the inverse of that fraction. 1 times x minus 4 squared over x minus 4 squared plus x squared, and we're multiplying by negative 4 over x minus 4 squared. And from here we can do some elimination. 1 times the 1 we can remove. Notice that we have in the numerator of the first fraction x minus 4 squared multiplied by a fraction whose denominator is x minus 4 squared. So the left numerator and the right denominator cancel. We're left with negative 4 over x minus 4 squared plus x squared. I'm going to expand the x minus 4 squared to x squared minus 8x plus 16. In addition, we have plus x squared. And now we will simplify to negative 4 over x squared plus x squared is 2x squared minus 8x plus 16. We'll factor out a 2 to get to negative 2 over x squared minus 4x plus 8. We've completed step 5. Our final answer, negative 2 over x squared minus 4x plus 8. We haven't been given an x input with which to calculate slope, thus step 6 of the algorithm doesn't apply to this scenario. We've completed all requirements of problem 2, and this concludes differentiation of the inverse tangent function.